Hello there, my name is David, and this is the shortest path in a weighted graph exercise for CST-215. I really can't believe this is the last exercise for the class, but anyways, we got to continue. For this exercise, I was to calculate the shortest distance between two nodes given by the user in this specific weighted graph. Before walking you through the program, let me run the code. The code begins by prompting the user which of the nodes of the weighted graph to begin with. We would like to choose 1 for our starting node, and to choose 5 for our ending node. And the program continues with a series of calculations known as the Dirac algorithm. I hope I pronounced that right. The algorithm seeks to find the shortest path in a weighted graph. This algorithm does this by tracking the distance between the start node and every node in the graph, seen here with D, every node's preceding node, seen here with S, the current node, P, and what nodes have been visited, right here seen in this in set. The program begins by initializing the given weighted graph. This graph was created by specifying the distance between each node and every neighboring node. For example, for the first node, its neighboring nodes 2, 3, 5, and 6 all had distances 3, 5, 8, and 1 respectively, and this was done for every node. After the graph is created, the start and end nodes are received from the user. With the graph, the start and end nodes, the shortest path can easily be found using the Dirac algorithm. We call the shortest path function the adjacency matrix, the start and end nodes. And the algorithm tracks the distance between the start node and every node in the graph, every node's preceding node, the current node, and what nodes have been visited. As said before. And now the algorithm continues in this while loop. It chooses the node with the lowest distance from the start node and adds it to the inset. It then iterates through the node's neighboring nodes that are not included in the inset and alters their distance from the start node if the distance of the selected node from the start node plus the distance from the selected node to the neighboring node is less than the distance of the neighboring node from the start node so far. This process is repeated until the end node is reached. Finally, the length of the shortest path is printed by simply outputting the distance of the end node from the start node. The path from the start to the end node is printed as well by calling the printPath recursive function, which recursively follows the end node's preceding node, the end node's preceding node, and so on until the start node is reached. Because the start node is printed at the bottom of the recursive call, the start node is printed first until the last node is printed. Thank you for watching.